These other graphs here, these are all much the same, except these are inequalities and we're sketching regions instead. So for this one here, it's at the centre. If we grab a hold of it and pull it across in the centre, the radius is 4, so I'd need to make this a lot bigger. 1, 2, 3, 4, so it's got to go out to here and still be in the centre. So if I put it in here, still not big enough. Okay, almost there. That's about near enough. Okay, so there's 1, 2, 3, 4. So that's your radius. Now it says to sketch this, the region. Now this is less than or equal to. So the region we'd be dealing with then is the region inside the circle, not outside the inside. So that's what we'd have to shade, that area inside. If I was really clever, I'd quickly click on here and do this and do that, and then fill in properties and the fill colour. Yeah, that'll do. And I go like that. So okay, that's the region. That's what it looks like, filled in or equal to. So it's sketching a region. If of course it was greater than, then we wouldn't have the centre filled, we'd have the outside filled. This next question here, what question is that? It's question 5. You've got this point and this point that says there's the ends of the diameter of a circle. So the 0.84, there it is over there, and the 0.22, there it is there, are the ends of the diameter of a circle. So that's our circle, there's the diameter, and it simply asks you to find the centre and the radius of the circle. So how are you going to do that? Well, here from the sketch we can see pretty well that the centre is at 2, 3, 4, 5, so it's at 5 and 3, so it's at the 0.53. So that's H, that's K. What about the length of it? How are you going to find out the radius given here? Well, here you're going to have to just be a little bit smart and use Pythagoras. So there you go, so that's up 1 and across how many? 3. So 3 squared plus 1 squared equals that length there squared. You don't even have to solve it, do you? Because, yes you do. You do have to solve it. So work it out. That will give you what R is, and then you put it into your general formula, because we've just worked out what H is. We've just worked out what K is, and that will let us work out what R is. And that's how you go about those. Next one, find the equation of the circle, which has a centre here. So the centre is at 2 and minus 3, so it's down here. And we just need to drag this across into here. Now it says which touches the x-axis, so this has to be stretched up to there. So stretching up, let's move the centre of my circle, so I've got to fill around it a bit. Keep going. Now I'm shifting axes. Okay, not perfect, but near enough. So that's our circle. So what have we got to do? Find the equation of it. Well, there's the centre. What's the radius? We can measure the radius pretty clearly from here. We wouldn't even have to draw this, you know, because you could have realised that it went 3, didn't it? It went up minus 3. So the radius is equal to 3, and we can then use that to draw our circle. Look, I think that's pretty well it. The rest of them are fairly straightforward. Here's your 3 points on the outside, so you're going to need to sketch that to work that out. This one here, just really very ugly question, but you're going to need to factorise this to get the circle. Same thing with this. When you've got the two circles, find the coordinates of the points of intersection. So do you even have to draw this? It's pretty nasty, but you just need to, I'd be dividing this one by 4 and see either using an algebraic method or a graphical method to solve it. I might leave that one with you, we can discuss that in class. Same thing with this one here. I'd be using an algebraic method to solve this particular one, and seeing when you can work it out. So for this one here, for example, here's your equation. Whoops, 25, isn't it? So whereabouts does it intersect with this one here? Well, it'll be where the points are common. So if it's the point where x is equal to y, where will that occur? Well, we can use this and substitute this in. So we can instead of writing, since x is equal to y, we can write y squared. We can write y squared as being x squared, can't we? Because this is what am I doing here? Made a mess. Hang on. So I can write it like this, and because y is equal to x in this instance. So that gives me 2x squared equals 25. I can halve that. And now I take the square root of this, and I'm going to end up with x is equal to square root of 25 is 5 over root 2. So that's what x equals. We don't leave it like this because it's a sin, as you know, to leave the denominator irrational. So we're going to end up with 5 root 2 over 2 as being the actual answer. And you do a similar thing then with this equation here. And that, gentlemen and ladies, is that.